Okay, ladies and gentlemen, welcome to the third of 4 videos for Chapter 4, Section 5 in your geometry textbook. This video is still working its way through the triangle congruence postulates. In this case, we're looking at 3 example proofs involving our congruence postulates. Again, the key here is being able to look at the problem and come up with which direction you're supposed to go, which postulate you're supposed to be trying to use. So again, every proof starts the same way. Again, this video is going to have 3 example proofs in it, and then we will have one final video covering the final bit of information from this section. So every proof starts the same way. We relist our given information. In this case, we are told that AD and CB are congruent, which is marked in the picture. We're also told that AD is parallel to CB, which is also marked in the picture. Now, the congruence statement we don't need to do anything else with, but they wouldn't have told us that those lines were parallel unless we were supposed to do something with that. In statement 2 of this fill-in-the-blank proof, we are told that angle BAD, which is BAD is this angle up here, is congruent to angle ABC, which is down here. This is based on our parallel given, because if AD and BC are parallel, then AB is a transversal, and the 2 angles listed in step 2 are alternate interior angles. And the alternate interior angle theorem says that if 2 parallel lines are cut by a transversal, then each pair of alternate interior angles must be congruent. Finally, in step 3, it says reflexive property. We notice that these 2 triangles are sharing a side, in this case side AB, so we are able to use the reflexive property to state that AB is congruent to AB. Notice what that gives us in the picture. We have our 3 required pieces of information: the top triangle, side, angle, side; bottom triangle, side, angle, side. So we have finished this proof under the auspices of the side angle side congruence postulate. On to the next proof. And again, you should pause the video and try the proof and then watch the video to see if you got it right. Okay? Pause the video, try the proof, unpause the video, see if you got it right. All right. So we start every proof the same way with the givens. DE is parallel to GH, and GE bisects DH. Those are our givens. Now, neither one of those is a congruence statement straight up, so we're going to have to deal with those 2 givens separately. It appears that we've decided to deal with the bisector statement first, based on the reasoning of definition of bisector. So we have to ask ourselves, what does GE bisects DH mean? Well, that means that GE is cutting DH into 2 equal parts. So if we go up here to the picture, DH must be cut in half, which would imply that DF is congruent to FH, because that is what bisect means. It means cut into 2 congruent pieces. Okay, then we have 2 sets of angles in step 3. So we should go figure out why those are congruent, because obviously they are, or it wouldn't be typed in there already. Okay? So we go up here to the picture and we say, why is angle D congruent to angle H? Well, it has to do with the parallel given. If these 2 lines are parallel, then DH is a transversal, and angle D and angle H are alternate interior angles. Same exact reasoning, EG is a transversal as well, and angle E and angle G are congruent for the same reason. They are alternate interior angles, and the alternate interior angle theorem says that they must be congruent. Looking at what we've marked, we have marked 3 pieces of information as being congruent. We have there 2 angles and a non-included side, so we have shown angle, angle, side. With one additional step, we could have declared vertical angles and done angle, side, angle instead, but the way this proof is written, this is an angle, angle, side proof. Once again, there's an additional proof on the next page. We're going to do one more on this video, so you should pause the video and try the 3rd proof, and then unpause the video and see how you did. Okay, here in this third proof, once again, we start every proof the same way with our givens. E is the midpoint of segment AD, and a segment AD is bisecting segment BC. Those are the givens. Now again, neither one of those directly states congruence, and we need it to state congruence in order to use it to prove congruence. So we start with the midpoint statement there. If E is the midpoint of segment AD, that means that E is exactly halfway between A and D, meaning that AE is congruent to ED. Now it's worth noting that that is definition of midpoint. It could also be declared the midpoint theorem based on the work that we have done this year, because we actually have a theorem that says that as well. Doesn't matter which reason you give, they're both correct. Now, in number 3, it says definition of bisector. So this is where we're going to use up our other given. AD bisects BC. Again, you have to ask yourself, what does that mean? Well, that means that segment AD is cutting BC into 2 equal parts, which means BE must be congruent to EC, because it's being cut in half by AD as being bisected. That is what bisector means. In step 4, we need to find these angles so we can figure out why they are congruent. So we trace them with our finger. Triangle AEB is this angle. Triangle CED is this angle. And then we ask ourselves, well, why are those angles congruent? Those angles are congruent because they are vertical angles. And the vertical angle theorem says all vertical angles are congruent. Notice what we have shown. We are finished with this proof. We are able to state that triangle ABE is congruent to triangle DCE because we have shown side angle side congruence. I think that does it for this video. Yes, it does. We have one video to go in the section which will cover the corresponding parts postulate, show what that means in terms of a non-proof example, and I believe we'll have a proof. Thank you very much for your time and attention.